Harald Eberle from the Vorarlberg State Library. Harald has been working as a system librarian at the Vorarlberg State Library since 2004. Since 2014, he has been leading the Volare Vorarlberg Landesrepositorium project and is responsible for digitization and provision of collections at the library as a technical expert. And the talk is about sMapshot, the participative time machine. I give you the floor.
Thank you. Thank you for the introduction. Glad to be here. Thank you for the new sticker, PHAIDRA guys. Yeah, I'm here to talk about sMapshot. sMapshot is a georeferencing platform that helps volunteers to locate and map historical oblique aerial photographs. Let me start with a few words about Volare. Volare is our dedicated PHAIDRA repository, which is hosted and operated by the University of Vienna. Currently, it contains about 380,000 images within 39 collections. As Rory outlined in a PHAIDRA community blog, we are using the PHAIDRA backend without its standard user interface. Instead, we have developed our own interface. This front end allows us dynamically merge the metadata from the ALMA library system and the images from PHAIDRA, presenting then the complete content online in real time. In addition to our images, we also publish many text objects, such as books or newspapers, but they are not stored in PHAIDRA. So now we will focus on the historical oblique aerial photographs. These are images taken from the air, typically from an aircraft, such a plane, a helicopter, or a hot air balloon. We currently manage 4 collections containing these types of images. The newest and largest of these is the collection from the company Aircolor. Between 1978 and 1994, this company took pictures of private homes and companies and then offered to sell them to the owners for a big amount of money. It's important to note that many of these pictures are still hanging in rooms throughout Vorarlberg today. People in this region have a strong personal connection to their homes and are generally very proud of them. The company Aircolor sold these framed images to the house owners for a value equivalent to roughly 1 month's average salary at the time. This demonstrates the high emotional and financial invest people made in these specific photographs. So why are these historical oblique aerial photographs so important beyond the personal connection? They allow us to draw conclusions about changes in land use and the wider landscape over time. Furthermore, they represent a valuable source of information for both planning and academic research. These images provide detailed views of buildings and landscapes, and the 3D effect enables a much better spatial awareness of the area. Let's look at the example. Here you see a photo from the area of Bregenz. When we look at the first image from 1959, you see mostly undeveloped land in the background. 30 years later, the picture has changed. Agricultural land had make way for a parking lot. And if we move forward another 30 years, you can see a large amount of residential housing. This new construction has displaced many of the green spaces. The Vorarlberg State Library was able to purchase the Aircolor collection from a private individual. The collection is massive, consisting about 37,000 color negatives. The challenge was that these negatives were unlabeled. We therefore started the digitization of the complete collection in 2022. So what's the challenge now? We currently have a lot of scanned images of buildings that we cannot identify or locate. A proper assignment and a correct library description are only possible if you have necessary local knowledge. For example, look at this image. This is a tile shop in Dornbirn. Without someone from the local community identifying it, we would not know exactly where this building is and what its historical context is. And this is exactly where sMapshot comes into play. We need to ask the volunteers with local knowledge for help. Geographical location data and a map-based search function offer essential advantages for researchers and the public. To georeference images, there are three different methods. The first is the point-based georeferencing. Everyone is familiar with this from the GPS coordinates on a smartphone. But where exactly should the point be placed? At the camera's location or in the center of the image? The second method is area georeferencing. This works very well for standard vertical photos, but is not suitable for our oblique aerial photographs because of the distortion and the angle. Finally, there's 3D monoplotting. This is the method sMapshot uses. We set control points both on the image and on the 3D terrain model. An algorithm then uses these points to calculate two things: the exact location where the picture was taken and the area visible in the picture on the map. So what are the main goals of sMapshot? First, sMapshot uses the geographical knowledge of volunteers. Second, we want to locate these historical pictures or images in 3 dimensions. And finally, once a picture is located, we can use the generated footprint, that is the visible area in the image, to calculate place names that are visible in this image. Regarding to the development, sMapshot was originally developed by the University of Applied Science in Yverdon, Switzerland. Today, about 16 institutions are using sMapshot. The largest partner is the image archive of the ETH Zurich, which has uploaded around 200,000 images. The majority of these images are already located by the volunteers. As for our specific collection, we have about 51,000 images online, and 30,000 of them are already georeferenced. So I try a short live demo. sMapshot is accessible via this URL you see on the top, and I try to start a browser. Here you see the sMapshot interface. sMapshot has 2 layers, the Discover layer and the Contribute layer. Under the Discover layer, we can see all images which are already referenced. On the left side, there is a filter. Here I can filter the view to the institution and the specific collection. Now I've selected one small collection, the so-called Alpine Luftbild. These are only about 300 images. And every point you see is the location where a picture was taken. And, if I move with the mouse over an image, I can see the footprint. This is the area visible in the photo. And clicking on such a point, I see the image in the front, and in the background, the terrain model with the actual orthophoto is shown. And here, I can play with the transparency. So this is the actual view and the historical view, or with the depth. So, and you see how accurate this georeferencing is. And here on the bottom, there are other already mapped photos, and if you click on one, the view flies virtually to the next image. And so I can navigate through the whole collection and see how the land was. Okay, let's go back to the presentation. Oops. So we briefly walk through the steps of georeferencing process is used by the volunteers. First, the volunteer sees a map that displays images that have not been processed yet. These images are already roughly sorted by cities. The volunteer can select an image from the map or from the bottom here. Once a volunteer finds an image whose exact location, they know they can start the referencing process with geolocalize. The very first step is to define the approximate camera location. To do this, I place a point on the map where I believe the image was taken. This is just an estimation to start the process. After setting this initial location, I click simply Next to go further. The next step is to define the viewing direction. We need the specific direction the camera was pointing when the photo was taken. Next, sMapshot opens a detailed map view for me. In this view, I can select background images from different historical periods. This feature is important because it allows me to match the historical photo with appropriate background maps, which helps in identifying specific landmarks. Now we come to the most important step, the actual 3D monoplotting. I need to find a minimum of 6 matching points between the image and the map view. This means I first select a distinctive point on the left side on the image. Then I find and select the exact same point on the right side on the map view. These points can be street intersections, the corners of buildings, distinctive trees, or similarly clearly visible features. The more precise these points, the better the final georeferencing will be. If all points set correctly, the system calculates the exact map location. The historical image will be overlaid on the current map. Finally, I have the opportunity to add an observation or annotation on the map. Here I can enter, for example, company names or mark other interesting points that are visible on the image. This additional input from local volunteers adds valuable data to the image's metadata. After the observation has been added, the georeferencing process is complete. I can go back, select the next image, and start the process again. Every submission is then reviewed by a library staff member. The staff member checks the quality, corrects its location if necessary, and finally approves the submission for public use. This ensures the high quality of our data. So, what is now the added value of this referencing for our repository? Once the image is referenced, we can display a map, you see this on the button, with the area that is visible in the image. This improves the searchability and the context of the image within our Volare system. In addition to the map display, we can also calculate new metadata. Every georeferenced image has a footprint, the visible area. This footprint can be intersected with various map materials. For example, we can intersect it with address data. These generated keywords can then be imported back into the metadata system, making the images much easier to find. Unfortunately, we don't do that yet. We are planning to do so in the future. So, finally, let me give a brief overview of the crowdsourcing success that helped us to process these images. In total, our volunteers have already located 30,000 images. On average, 90 pictures are processed every day. The average effort required per picture is about 5 minutes. If you calculate this in total, it comes about 2,500 hours of volunteer work that has been dedicated on this project. This highlights the incredible community effort behind sMapshot. A large part of our community was already part of the Swiss sMapshot community. These are mostly retired men who are very skilled at working with maps. We also wrote the archives in Vorarlberg. We asked them to help us and edit the images in their region. In these types of crowdsourcing projects, it's also very important to interact with the community. To facilitate this exchange, we have already held 2 crowdsourcing workshops. You can see a few images from the very first workshop highlighting the importance of the personal interaction with the community. So that brings me to the end of my presentation. Thank you for your attention, and if you have any questions, feel free to contact me. Thank you.
I want to ask, this is about aerial photographs.
Yes.
Yeah, how can I know if an old photographs has been taken from the surface or from, I don't know, flight? Sometimes I can't decide if a photograph has been made on the terrain.
Okay.
And second question, is there a copyright issues about using photographs? You know, sometimes the postcard photo in postcards. Sometimes I think they are out of copyright, but I'm not so sure. And so the process of provide photographs, how can we deal with that problem?
Okay.
Thank you.
To the first question, now it's only possible to georeference images which are taken from the air. If you try to reference images from the ground, the referencing does not work. The system says, okay, the points are not matching because the distortion and the angle is too strong. And to the second question, we only publish images with an Creative Commons license. We don't use postcards for this because there are legal issues. So that's the answer.
Well, first of all, compliments. It's really impressive, the work you have done, really, really very much. I'm curious about the engagement strategies you already put in place, or maybe you want to extend, to experiment in order to extend the pool of volunteers, because it's clear that you have Klaka, who is doing a lot of stuff. But also when you check number 10 or 11, it's just 79 or 7. So I imagine there are opportunities to extend also other generations, I don't know.
Yeah, that's true. We are in the lucky situation that the Swiss community reference our images. We tried to invite local people in Vorarlberg to do this, but there are only a handful of people are coming and help us with this process. So we try to use the archives, the archives to help us, and in some regions they did, but not overall. So we try and we hope that there are a lot of people coming and help us.
Maybe I have a question about digital. Oh, sorry.
I think it's a great example of what PHAIDRA is able to do, that you can have a big data set and still use it. Do you happen to know if there are plans from other countries to also use sMapshot with a similar setup maybe?
Also, I know that currently are using about 16 institutions using sMapshot. There is a big part is Switzerland, some are in Germany, one partner is in Brazil. So sMapshot has, they had to develop sMapshot that the whole world is usable. First, only Switzerland was usable, so they had to put the whole terrain model from the whole world into sMapshot that this works. But I don't know if there are any other institutions waiting for add their images in sMapshot.
My question is about digitization. I see you had a great amount of color negatives.
Mm-hmm.
How did you, in which way did you digitize them?
We didn't do that ourselves. We had a company that do that for us.
Okay.
And yeah, we have to pay for this and they do that for us, yeah.
Okay. Thank you. As we will have also collections of negatives for the history of medicine, so I was curious to know how you have done it.
Okay, yeah.
Thank you.
Thank you.